Good morning, dear children. So, yesterday we learned about naming different organic compounds. So, we learned how to name different organic compounds using functional groups, using primary suffix, secondary suffix. So, what is the general format for naming organic compound? First of all, prefix. And what are the prefixes we use? We use halides and alkyl groups as prefix, and then word root. Word root means number of carbon atoms in the main chain, in the parent chain, are termed as word root. And then primary suffix n, in, in. Then secondary suffix as carboxylic acid, for carboxylic acid, oic acid, for alcohol, ol, and so on. So we learned that. Then we learned that the preference, the preference of getting the lower number should go with the in, and those functional groups which comes under secondary suffix. Then if there is no secondary suffix and no in and in, then prefix will have the highest preference. So regarding all these things we learned yesterday. So today we'll be learning isomers. So what are isomers? Compounds having same molecular formula but different structural formula are known as isomers. Iso means same, and here meros means parts. So same parts. The molecular formula is same, but structural formula is different. So isomers differ in physical properties or chemical properties or both. So they may differ in physical properties, they may differ in chemical properties, they may differ in both. So it is not like that, okay, they are isomers, then their chemical properties and physical properties will be same like isotopes. No. Isotopes will have similar chemical properties, only physical properties will be different in isotopes, but in isomers only molecular formula is same. Number of atoms of different elements present in a compound is same. That doesn't mean the compound is same. So they may have different physical properties only, or they may have different chemical properties only, or they may have different physical properties as well as chemical properties. So we can illustrate isomerism by referring to two different compounds, butane and isobutane, both of which have the molecular formula C4H10. So you can see here, main chain has 4 carbon atoms. There are 4 carbon atoms in butane, and there are 4 carbon atoms in isobutane as well. There are how many hydrogen atoms in butane? There are 10 hydrogen atoms in butane, and there are 10 hydrogen atoms in isobutane as well. So what is different here? C4H10. Both the compounds have 4 carbon atoms and 10 hydrogen atoms. Means their molecular formula is same. So what is different then? So what is different is the structure is different. Here in the main chain there are 4 carbon atoms, in the parent chain, in the word root. But if you see isobutane, it will have only 3 carbon atoms in the main chain, and 1 carbon atom is branching. Means it has got one branch, it has got one prefix. Okay, it has got one prefix as methyl group. So this is the reason why their physical chemical properties will be totally different. Liquefies. So butane liquefies at 0 degrees Celsius, whereas isobutane liquefies at minus 12 degrees Celsius. The following flow chart shows different types of isomerism. Structural isomerism, and stereoisomerism or space isomerism, or that is also called geometrical isomerism. So regarding this geometrical isomerism or stereoisomerism, you will be learning in the higher class. So today in this section will be learning structural isomerism, and in this structural isomerism also we will be learning chain isomerism and position isomerism only, which is there in your syllabus. So in your syllabus, functional isomerism and metamerism is not there. There are two main causes of isomerism. So what may be the cause of isomerism? You must be thinking. So difference in the mode of linking of atoms. So how atoms are linked, that is the main reason there are isomers. So for isomerism, what is the first criteria? Why there are isomers? There are isomers because of the linking of different atoms. Like carbon atoms may link to carbon atoms. Carbon atoms may go in the branching form, so they have different mode. Now for example, C4H10O shows different types of linkage, and thus it stands for three different types of ether. This type of isomerism is structural isomerism. So, for example, C4H10O shows different types of linkages, and thus it stands for three different types of ether. This type of isomerism is structural isomerism. So, you can see here O, oxygen is in between two carbon atoms. That means in towards the left of oxygen two carbon atoms are there, towards the right of oxygen two carbon atoms are there, and this becomes diethyl ether because on one hand of the oxygen there are two carbon atoms, so ethyl group, and on the other hand of oxygen there is another ethyl group. So if there are two same kind of alkyl groups, then we say di, tri and all. So there are two ethyl groups, so we say diethyl, and since functional group O is there, so we say ether. So diethyl ether, whenever O is there, whenever O is linked directly with two carbon atoms, then that becomes ether. So this is diethyl ether. And then in the second figure, if you can see, in the second structure, if you can see, oxygen, on the left hand side of oxygen is one carbon atom, and on the right hand side of oxygen is three carbon atoms. So one side there is one carbon atom, that becomes methyl group, and on the other side there are three carbon atoms, which becomes propyl group. So what will be the name of this compound? Methyl propyl ether. Then other, you can see, on one side of oxygen there is one carbon only. On other side of oxygen there are three carbon atoms, but they are linked in different way. So they are linked in branched way. So they become now methyl isopropyl ether. Methyl isopropyl ether. That means in methyl propyl ether, all carbon are linked to one carbon each, but in isopropyl ether one carbon is linked to two other carbon atoms, hence it becomes isopropyl. Then different types of structural isomerism are chain isomerism and position isomerism. That only what we'll do in this class. So chain isomerism, when two or more compounds have a similar molecular formula but are different in the arrangement of carbon atoms in straight chain or branch chains, the compounds are referred to as chain isomers, and the phenomenon is termed as chain isomerism. So what is chain isomerism? When two or more compounds have a similar molecular formula but are different, so this isomerism means they must have same molecular formula, so their structure only should differ. So in what way the structure will differ? In this case, the linking of carbon atom will be different. So chain isomer means either they will be linking straight or they will be linking in branched, as a branch. So to a chain isomers, you can see here pentane C5H12. Pentane, Here, all carbon are linked to the straight chain. But in isopentane, one carbon is linked to second carbon. That means second carbon is linked with 3 carbon atoms. Second carbon is linked with 3 carbon atoms. So it is branching. One methyl group is branching. So its name will be 2-methyl butane. And down, if you see, one carbon is linked to 4 other carbon atoms. So in simple pentane, long chain will have 5 carbon atoms. In isopentane, long carbon chain will have 4 carbon atoms. In neopentane, long carbon chain will have 3 carbon atoms and 2 are branch. So in this way, chain isomers are formed. So position isomerism, when two or more compounds with the same molecular formula differ in the position of substituent atom or functional group on the carbon atom. They are called position isomers, and this phenomenon is termed as position isomerism. So in chain isomerism, what you could see is carbon is either linked in a straight chain or carbon is linked as a branch. So that makes the difference in structure. But in position isomers, what is there? Functional group will be linking with the different carbon atoms. Then also molecular formula will remain same. But the structure will differ. So you can see here C4H6 butane has 2 isomers. So butane has 2 isomers. Butane means it can have how many carbon atoms? 4. So either if triple bond is between carbon number 1 and carbon number 2, then also molecular formula will be C4H6. And if triple bond is between carbon number 2 and carbon number 3, then also it is C4H6. But their name will be different and their chemical and physical properties will be different, but the molecular formula will remain same. So what is differing here? Here the position of functional group differs. In chain isomers, the linking of carbon atoms as a branch or straight chain, that makes the difference. But in position isomers, what differs? Position of functional group differs. Position of functional group differs. Then you can see here pentane 3-one and pentane 2-one. So in pentane 3-one, C double bonded to O, that is ketone group, is in which carbon atom? 3 carbon atom. In third carbon atom there is ketone group. And in here pentane 2-one, carbon atom, second carbon atom is a ketone group, second carbon atom. So ketone group is in second position here and ketone group is in third position here, which makes the structure different. As a result, give rise to position isomers. So that's all about isomerism. That means in isomerism you need to learn only 2 isomers, chain isomers and position isomers. Let me repeat it again. In chain isomers, you can directly go on counting the carbon atoms in a straight chain and branch chain. So if they differ, carbon number of carbon atoms differ in the straight chain, which give rise to different structures. As a result, they form chain isomers. But in position isomers, position of functional group differs. So now we'll be starting hydrocarbons, alkanes. So alkanes are hydrocarbons in which all the linkages between the carbon atoms are single covalent bonds. So alkanes, what are alkanes? Alkanes are hydrocarbons having having carbon-carbon single bond, having carbon-carbon single bond. So what is the general formula of alkane? CnH2n plus 2. That means if there is one carbon atom, then there will be four hydrogen atoms, and this forms methane. So this forms methane. So methane is the simplest hydrocarbon. Methane is the simplest hydrocarbon. These compounds, alkanes, are also known as saturated hydrocarbons since all the four valencies of carbon are fully satisfied in the formula. The simple alkanes share many properties in common. All enter into combustion reaction. So you can see here methane, the structural formula, and ethane C2H6. If you put it in formula, you will get it. If carbon number is 2, hydrogen will be 6. But if you see here methane, ethane, propane, normal butane, pentane, and hexane, the consecutive compounds will be differing by CS2 unit, and this is homologous series. So you can draw this structure also. And then so they react with oxygen to produce carbon dioxide and water vapor. In other words, many alkanes are flammable. This makes them good fuels. So all alkanes are good fuels. Whenever they comes in contact with oxygen, they react, they burn to give carbon dioxide, water vapor, and light and heat as well. For example, methane is the principal component of natural gas. So methane is present in natural gas, and butane is common lighter fluid. So when methane combines with oxygen, it gives carbon dioxide and water vapor. These hydrocarbons are relatively unreactive under ordinary conditions, and so they are also known as paraffins. So paraffins, what do you mean by paraffins? Param means little, affinis means affinity. So paraffins. Then you could see here the condensed formula also. This is structural formula, this is condensed formula. So what is the difference between structural formula and condensed formula? In structural formula, all the bonds will be shown, but in condensed formula, bonds are shown between carbon and carbon only. Bonds between carbon and hydrogen is not shown. And if you do not show any bonds, then also it becomes condensed formula only. Then generally regarding alkanes, we need to learn about methane and ethane as per your syllabus. Why methane is called marsh gas? Because it is found in marshy places. So what is marshy places? Marshy places means the place which is always muddy in nature, where water content is there. That means which never gets dry. So marsh gas is formed at the bottom of marshes due to the fermentation of cellulose by a special type of bacteria. So whenever leaves or branches comes down, and then when they start decomposing in presence of water, moisture must be there. Not only moisture, marshy means a kind of slashy, means the content of water in the soil must be very high. So it is also present in the air exhaled by animals whose food contains cellulose. So it is present in the air exhaled by animals whose food contains cellulose. It is contained in intestinal gases and in the blood of animals and human beings. Why? Because it is what is the specific nature of this methane gas? It is present wherever there is cellulose. That means fermentation of cellulose. That means digestion of cellulose in absence of air by some bacteria is the main reason for the formation of methane gas. It is cavities in coal contain 90% 90% methane. it is called fire damp. Cavities in coal contain 90% methane. It is called fire damp. Methane is produced also by dry distillation of wood, peat, coal, etc. So cavities in coal contain 90% methane. It is called fire damp. Methane is produced also by dry distillation of wood, peat, coal, etc. Then ethane. It occurs to the extent of 10 to 20% along with methane. That means along with methane, ethane is also present. That means in methane only, wherever you think that methane gas is there, 10 to 20% ethane is also present. Methane is primary constituent of natural gas. It absorbs outgoing heat radiation from the earth. That means methane is also called greenhouse gas. It helps in trapping. Okay, it traps sunlight and does not allow it to go back, which results in the warming of earth. Okay, so this is the reason why methane gas is also called greenhouse gas. Methane remains in the atmosphere for approximately 10 years. It is 20 times more effective in trapping heat in comparison. So that means the production of methane gas is more dangerous, harmful than that of carbon dioxide, because it remains 10 years approximately in atmosphere, and it can trap 20 times more means heat as compared to carbon dioxide. Methane is emitted from variety of natural and human influence sources like landfills, natural gas and petroleum systems, agricultural activities, coal mining, stationary and mobile combustion, wastewater treatment and certain industrial processes. Methane is an important energy source, so efforts to prevent or utilize methane emissions can provide significant economical and environmental benefits. That means in order to rather than exposing it to the atmosphere, we can utilize methane because it is a good source of energy. So it can be utilized for producing energy, for doing a lot of work. Then how do we prepare methane? Lab preparation of methane. How do we prepare methane in lab? So what are the things we use for preparing methane in lab? Sodium, what are the reactants? What are the materials required? Chemical materials required for the preparation of methane? Sodium ethanoate, means it is sodium ethanoate. What is the chemical name for this? Sodium ethanoate is its chemical name. Then its common name is sodium acetate. So what will be its formula then? CH3COONA. What is the formula for sodium ethanoate? CH3COONA. There has to be two carbon atoms since it is ethane. And since it is ethanoate, so CH3COONA. So it is ester actually, sodium acetate. And then another reactant uses soda lime. So soda lime is in the form of a white porous mass or granule. So how do we get soda lime? Soda lime is in the form of a white porous mass or granules. It is a mixture of sodium hydroxide and calcium oxide. So what is soda lime? It is a mixture of sodium hydroxide and calcium oxide. When we mix sodium hydroxide and calcium oxide, soda lime is formed. And when the soda lime is treated with sodium ethanoate and the mixture is heated, then methane gas is formed. So let's see what is the procedure for this. A mixture of sodium ethanoate, sodium acetate and soda lime is taken in a hard glass test tube as shown in figure 12.2 and heated over a Bunsen burner. Then sodium acetate plus soda lime. Sodium acetate plus soda lime is heated in a very hard glass test tube. Whenever it is heated, it starts melting. Then a kind of gas comes out, and this gas is taken to another vessel with the help of a delivery tube, and this delivery tube is is immersed into water and one of the test tube is inverted into water, and then through the downward displacement of water, methane gas is collected at the bottom of the test tube. At the bottom, why I am saying, because the test tube is inverted, so at the bottom. If you see the figure, then it is at the top, but if you see the test tube, then it is at the bottom of the test tube. Methane gas is collected by the downward displacement of water. So why do you think it is done by downward displacement of water? It must be because methane gas is not soluble in water, and then methane gas is lighter than water. This is the reason why methane gas is collected by the downward displacement of water. So reaction, what is happening? CH3COONA plus NaOH, and CaO is also there. So NaOH plus CaO makes soda lime. So CH3COONA is sodium ethanoate or sodium acetate. When reacts with sodium hydroxide and calcium oxide, the mixture soda lime, at 300 degrees Celsius, then sodium carbonate and methane gas is formed. So how do we collect? The gas evolved is collected by downward displacement of water, since it is slightly soluble in water and is lighter than air. So why it is collected by the downward displacement of water? This may be the very important question which can be asked. So what is the reason why it is collected by downward displacement of water? Since it is slightly soluble in water and is lighter than air. It is lighter than air and water, and it is slightly soluble in water. That's why it is collected by downward displacement of water. So why it is said downward displacement of water? When this methane gas goes up, then the space will be occupied by methane gas. As a result, water falls down, water comes down. So it is called downward displacement of water. Then how is ethane prepared? Ethane is also prepared in the same way as it is prepared as methane is prepared in lab. But one thing is only different, that is reactant. In case of methane, we were using sodium ethanoate. In case of ethane, we will be using sodium propanoate, or sodium propionate and soda lime. So everything is same, only what is the difference? The difference is in reactant, the difference is in chemical material required. Okay, so in case of methane, sodium ethanoate is required. In case of ethane, sodium propanoate is required. So procedure is also same. A mixture of sodium propionate and soda lime is taken in a boiling tube and heated over a Bunsen burner apparatus similar to figure 12.2. Reaction taking place is C2H5COONA. As a result, how many carbon atoms are there? 3. So it becomes prop. And it is ester, so it is propionate. And since it is sodium, so sodium propionate plus sodium hydroxide and CaO, soda lime, at 300 degrees Celsius gives sodium carbonate and ethane. So among the two, what is the difference? Is the difference is in one of the reactant and one of the product. The rest is same. The gas evolved is collected by downward displacement of water. These gases, this ethane and methane, can be prepared by other way also, other methods of preparation of methane and ethane. So in your syllabus, it is there, the iodomethane, the preparation of methane using iodomethane, and the preparation of ethane using bromoethane. So iodomethane, when reacts with hydrogen, that means methyl iodide. Iodomethane is also called methyl iodide. So methyl iodide is common name and iodomethane is IUPAC name. And bromoethane or ethyl bromide are reduced by nascent hydrogen. Nascent hydrogen means hydrogen in atomic form at ordinary room temperature. So you can see hydrogen is replacing this iodine, or iodine is replacing hydrogen. Okay, iodine is replacing hydrogen. That means hydrogen is reacting with iodine and forming hydrogen iodide. As a result, hydrogen is moving towards iodomethane and forms methane. So similarly, ethane is also prepared. Nascent hydrogen is produced by the action of zinc powder and dilute hydrochloric acid. So how do we get this nascent or atomic hydrogen? When we react zinc powder with dilute hydrochloric acid, we get nascent or atomic hydrogen. Then other ways are also there. When water is added at room temperature to aluminum carbide, methane is prepared. And ethane is also prepared from alkyl halides. When methyl iodide or methyl bromide is warmed with sodium metal in the presence of dry ether, ethane is produced. But this is not there in your syllabus. In your syllabus only one, that is iodomethane. Preparation of methane from iodomethane and preparation of ethane from bromoethane is only there. This much for today. Thank you.